Ok, donc là on est sur le stand de la Slovaquie, so hi. Can you introduce yourself?
Hi, my name is Jacob. I'm from Slovakia and I'm here in Evsis presenting my project about a lot of stuff.
Okay, so we have a lot of robots, so we just seconds. So can you explain the first robot?
Yeah, like my project started as a robot for RoboCup Junior Soccer competition. It is a competition where two fully autonomous robots play against each other, like robotic soccer. It is a really cool competition, so if anybody want to try it, I really advertise it. And in this robot you need to deal with a lot of systems, for example movement and so on, so on. But my main focus was on visual system to detect position of balls and goal and other robots on the field. So I created my own neural network architecture, convolutional neural network architecture, that I then implemented on TPU. It is like special IC, integrated circuit, that can do some certain operations really fast. For example, matches, multiplications, and so on and so on. That's, for example, like activation functions. And I developed this robot, and like I was able to win RoboCup with this robot as well. And from this, I wanted to create some useful product for industry. So I ended up creating my own camera that contains this TPU and can run like operating system. It is really cheap, it is really modular, and it is already used in industry, and I sell a few of these, and yeah, it is really cool. And after I created this camera, another thing I would like to say is that everything is open source. So everything you can find on the internet, everything you can modify, and everything you can make better yourself. And after I created this camera, I saw a few of these, and I ended up creating my own way of computing images, or to extract some information from images. So I created my own fully parallel neural network accelerator camera that has like 28 by 28 sensor of phototransistor, and every one of these phototransistors are pinned out. And so what this means that you can take the whole image at once. And I also created the parallel neural network accelerator, analog neural network accelerator. So it means that you can just take the whole images, whole analog voltages, and put it in the input. And and you can just take it as the whole thing, put it inside the neural network. It will go through, and in the output you will get your data. And what is the
How is it different from a normal camera processing an image?
Yeah. Okay, so what is different? Like in normal processing of image, you have a camera sensor, and you use multiplexers on each side and read the whole image as pixel by pixel, then save it into memory and send it through some serial interface out, and then process it to CPU or GPU and so on, so on, so on. But these make really like some delays and create some bottlenecks for image processing. So I created it that way that you can take voltage of every one single pixel in your camera at once, take it at once, put it in neural network at once, and process it at once. So it is really fast. And what are advantages is that it is really robust. So for example, when one part fails, the whole thing will continue working. If another part fails, it will continue working. And if like 10% of whole thing fails, it will continue working, but like more like it will just decrease the preciseness. But what is different from like classical approach? For example, if you have server, you have like two CPUs there, and when one fail, the other will continue working. But it doesn't. It can mean that only one transistor will fail in the CPU, and the whole CPU will fail. And in my architecture, something like this won't happen, because like it is really robust. Created this way. Okay.